At the outset, I should say that my colleagues could not make it, so as he explained, I'm standing in for them. I'm not an expert in this, so I hope the questions could be answered by someone in the audience itself. But I'll just run through what were the thoughts of our company. Before that, a little bit about our company. We have 4 business areas. DNVGL provides advisory services and many certification services. So under energy, we do a lot of work related to our work, renewable energy, and we had integrated the various companies we have acquired. That's where our expertise is coming from. So the first is, this is a very controversial topic today in India. It's a very interesting, it's a very essential, but there are different stakeholders thinking in different lines. They have problems at every stage. So this is a topic, as many of you are aware, which needs to be addressed, but then there are different perspectives to it. So as you know, the 2 examples why grid codes must exist, because one is the frequency response and the other one is a fault current injection. So when you say, since you can't store power, you need to balance between consumption and generation. And since the generation from the renewables are not consistent, because the wind is not consistent and also solar, there is going to be issues on that. When you have combination from different sources, you will have this problem. So there is a requirement for a fault right-through mechanism. There are various ways it is done. So what we do generally is to detect the imbalances through frequency response, and then we have fault through, right-through, which is established through voltage dips, which might happen. We need to protect the grid against that. So the key issue is to provide the consumer the quality power continuously at a rate which is economical. So with this agenda in mind, if you look at it, what's happening is there could be under voltage right-through, which should be there, a low voltage right-through, which should be there as well. So this would, in fact, effectively protect the grid or even the generators from any eventualities which could happen. So with this background, if you look at what should be done is there are ways on which you can test it. So you get an LVRT to meet a certain specification. So first you get it designed, constructed, manufactured, and put it through a type approval to a certain standard, and that would be common across. And then you need to bring it to a particular site, a particular type, you could say. If it's a wind turbine, a type could be done, and then you do a test at that particular place, because you need to ensure that the installation is really meeting the requirements of the grid at that particular location. So there is a physical test is required as well. So frequency response for wind turbines or PV inverters in India, still it is no, though there have been regulations which we will see coming. It's not fully implemented. It's there in parts, it might be there in future, but as of today, it's a no. And similarly, over voltage requirement also, right through, is also not required in India now. Low voltage right through is required in India, yes. And there is a requirement by CEA, but then implementation is got into some trouble, and it's also progressively being done. There are some technical issues and there are some commercial issues. We are not getting into that at this point. Active current injection, yes, in proportion to retained voltage, and reactive current injection, yes, for 300 milliseconds or till voltage recovers, whatever is first. So this is specified. Specific characteristics defined, yes. So these are in place. So if you see grid codes for India, CEA has made these requirements, and then there could be local codes in addition, because we have a federal setup. State governments may have uniqueness where there is more wind or there is more sun. They could have more challenges in the local grid, so they could come out with their own codes as well. So if you are trying to fulfill, you should fulfill both. And requirements are summed up on the right-hand side, what I've gone through. So what exactly is required? CEA requires a lot For example, under voltage write-through, there's a low voltage write-through. It should have harmonics, control, reactive power compensation, AVR, PSS, and synchronous condenser mode, etc. Whereas MNRE, that is another agency which is involved in it, via RLLM only requires LVRT. So there is a difference between the two agencies which have coming with a requirement. And coming soon, LVRT is also required for PV inverters because there are more solar installations coming and the more problems are coming, and there is maybe a requirement for HVRT as well, and there should be a frequency response, ramp rate limitations, AVR also for PV and wind, and compliance monitoring. So this is the current scenario which is going to emerge. Where there is a conflict is where the CEA requirement has been implemented, but then there are some stakeholders who would be affected. I'm sure the next speakers would touch on it. So that's where we are stuck at this point. I think we would see, if you look at holistically, this may be a progressive improvement, partly because there is more knowledge and technology available, and also the generators are changing in technologies as well. And there is more experience being gained in the countries which have gone forward for this. So all these together is the problem in front of us right now. Who requires to comply with grid codes in India? Historically, first, wind turbines can do LVRT. PV will be following, probably with LVRT, and perhaps HVRT, and then the rest, the other sources of power. So if you look at the revised list of models and manufacturers of wind turbines which have been announced by government, it is historically first to pass a government listing in India. So the first time government came with a wind turbine list, and main concern was first the structural integrity. Earlier days, what was thought was structural integrity is very important, but now there is a realization with growing number of installed generators coming in, LVRT is additionally required. And solution in India, RLLM with type certificate, so which means structural integrity needs to be protected, plus a statement of compliance to LVRT. And there is a confusion in the wording, which will be explained later, because those people who are involved in the certification business, like ours, know the finer difference between the words between statement of compliance and certification. And the competent authority, of course, is Ministry of New and Renewable Energy, formerly NIWE. So if you go into the requirements, there is an LVRT compliance as per applicable CEA technical standards for connectivity to the grid, and it talks about demonstrated in statement of compliance. So the type certificate have different scopes here. You can have grid codes only, because we have a centralized control based in Germany. There's a technical manager who controls the grid code compliance all over the world. And we have common processes, common procedures, and we also have a standard, which is mentioned in the notifications as well. It's a GL standard, is accepted. It's also equivalent to the IEC standard as well. So grid code compliance, there can be a type certificate. That will help first when you produce and then bring the machines onto the market. It could avoid blackouts. Following rules from CEA will avoid blackouts. It could certify CEA compliance by qualified independent certifying bodies. So like us, there are other bodies as well. So it's very important to have them certified when it comes in. After that, there is also a draft grid code which is already published by CEA. It talks about technical standards for connectivity to the grid code. That's how. Then once having come into the market, you have to bring it to the site and again test it, whether it's really working to the requirements of the grid locally. So that's where a testing equipment is required. So there is a generator simulated, or you get a generator in this container, and then you have monitoring equipment inside that. So our team will come and set it up and then do these measurements for all types. And then we issue a certificate or a statement of compliance. So what we do is, there is a IEC test. There is a slight requirement different way it's expressed in CEA. the CEA gives on the x-axis, for example, a logarithmic scale in timeline, whereas IEC specifies slightly differently. So we'll not go into technicalities, but the requirements are slightly different. So when we do the type approval certificate in the factory, or when it comes out, it would be against the IEC requirement, and then you bring it to the site in India, for example, and then you test it at the local grid location. So IEC testing cannot prove CEA requirements, because CEA requirements operate in a very specific area. So they have defined this curve in the guideline. So there is no IEC test in this area between the green line and the blue line. So that is where the relevance of a site test is important. So at the moment, site tests are not mandatory, but it's very important to have this measurement testing done in order to really protect the grid. LVRT should have a specific test plan. It ensures to cover CEA requirement. So that has to be established between the generator and us. And then we'll draw a test plan specifically following our standard specifications, service specifications, which are available. And then we do the assessment of the requirements against the CEA requirements. And then we issue what is called a statement of compliance for LVRT. This methodology is a non-governmental certifying body accredited by CEA, for example. So CEA authorized people. That ensures the right competence is used and the methodology and the process used are robust. It serves the purpose. It's relevant to the local conditions. It's also a proof of evidence of LVRT in India. And it gives you some assurance that the grid code is complied with. You can have individual wind turbines checked. This is one type of control which can have plant control for individual turbines, or you can have for all of them together in a single plant control. So you could have both combinations, configurations which are existing. So ideally, this should be also spelled out. So for solution for foolproof CEA requirements, unit level, power generating unit models are available in the market, type certificate for grid code compliance, and then component certificate for plant control device, and the specific simulation model validated against test results. At the plant level, you require power stations with collected wind or photovoltaic power, the project certificate for each single plant or power station at a given site based on the existing certificates from the unit level. So we need to do a testing at the site, then we issue a type certificate for grid code compliance against CEA requirements, and a type certificate for structural integrity as well as per IEC requirements. These together would fulfill those requirements. And then compliance monitoring, regularly checking of settings, new regulatory requirements come, or any need for harmonics which develops, and there is a regular checking which is required to make sure that the generators remain appropriate for the grid at that particular location. So just to sum up now, grid codes help prevent blackouts. So there have been many incidents. Many of them are not published, but I know that people who work in the distribution companies and transmission operators, they are aware. Some are available in public domain. The grid code for India is from CEA, but MNRE requires wind turbine type certificate for structural integrity plus statement of compliance for LVRT only. Approval takes place via RLMM process. So they need to harmonize both. LVRT will soon also be required for PV inverters. So we should have enough manufacturers, we should have capabilities, we should specify the requirements. IEC scope of LVRT testing is not sufficient to prove compliance for India. So there has to be separate site-specific testing which is required. And LVRT is not the full scope required by CEA. And full scope of CEA requirements as far as applicable to the unit level can be covered by type certificate for grid code compliance. To prove full compliance with CEA, each site with a PV or wind power station needs a site project specific certificate based on existing type certificates. Plant control equipment can become certified, and simulation models can be validated against LVRT test results and certified. DNVGL also provides tailor-made solutions. So what at the end is agencies like us can provide is the support to make sure that it's not only type approval at the factory stage, it's also at the project stage. This will become important in future as the grid goes, generators grow, and the complexities also will grow. Currently, we have a testing process which is going on in Chitradurga. We have brought this container from abroad. It's going to be there in India. So it's available for all the generators in due course of time, and we have a lot of expertise all over the world. We constantly monitor the grid code changes in different countries, so we are in a position to advise on what might come in future, or we can even present the problems. Lately, we had an opportunity to interact with personnel from different agencies in CEA, SRPC, and others. We provided them the training in Germany and Spain, and there have been a lot of interaction happening at different levels as well. So that's the way we work in this industry to make the end objective possible. Thank you.